Good morning, everybody. Today we're going to talk about ARCSIN, ARCCOS, arctangent, all the trig functions with their inverse function. We're going to just look at how it works to start. Then I'm going to show you how to find the angles in a triangle given all the sides with this process. So for starters, you may have seen something like ARCSIN. Also, if you have sine minus 1, with a little minus 1 up there, that means the same thing. Or we'll say inverse cosine or even inverse tangent. Those mean the same thing. On your calculator, if you look up above the sine, cosine, tangent, you see a sine minus 1, cosine minus 1, tan minus 1. Those are the inverse trig functions. So let's just kind of start out dealing with kind of what they are. Typically, if you have just a regular sine, this is the input, that's the output. With a regular sine, you put, say, 30 degrees into sine, and it says, well, that's a half. This is the in, and that is the out. And you can kind of recall that, clear everything out. I can't remember if I'm in degrees or not, so I'm going to push mode. I actually am in degrees, but if you wanted to change to radians, you'd scroll down and hit radians. So currently, sine of 30 degrees is a half. What the inverse does is it switches the input and the output. So you might say arcsine of a half, or you could say inverse sine of a half. Those mean the exact same thing. Those equal 30 degrees. So the inverse trig functions basically answer the question, if I got a half as my output, what was that angle? So if you just want to see this second sine right there, that's inverse sine of a half, gives me 30 degrees. If you're doing this in radians, 30 degrees is pi over 6. If I just went down to radians real quick and did inverse sine of a half, you would get a really ugly decimal, which is pi divided by 6. So let's I'm going to go back to degrees. Let's practice using this on a triangle. There we go, degrees. Actually, before we do that, let's just try one more of these. Let's do an unusual angle. Say you do cosine. Going to make this up, 54 degrees. I don't know what that is. Cosine 54 degrees is 0.5877. So 0.58779. If you wanted to do inverse cosine of 0.58779 and ask the calculator what angle would have given me this, you could do second cosine 0.58779, and it gives you 54 degrees. So it's just a way to say, hey, what was that angle that we used to get that number? So let's look at a triangle. So this is a right triangle. And I'm going to just make up some numbers. Let's do, this will be 10, this will be 5. I'll make this question mark for now. With the Pythagorean theorem, you know 5 squared plus 10 squared equals question mark squared. So this is 25 plus 100 equals question mark squared. And that's going to be 125. So if you take the square root of that, this is going to be the square root of 125. Okay. So let's say you want to know the angles here. We'll do theta 1, theta 2. For theta 1, you can pick any trig function you want. Maybe we'll just do sine. So I know that sine, let's kind of box that off, equals opposite over hypotenuse. So sine currently is going to be 10 over that. So knowing that sine is 10 over square root of 125, I want to know what that angle is. So I'm going to do inverse sine, or you could say arc sine. They mean the exact same thing. And we're going to just hammer that out. Clear. Inverse sine of 10 divided by square root 125. So I just did inverse sine of this, and it's going to spit out my angle. Call that 63.4 degrees. And now, knowing that these two have to add up to 90 because that one's 90, you could do, 90 minus 63.4, and you could have figured out that was 26.6. But let's just, figure it out using inverse trig functions. I'm going to call that theta 2. That's currently called theta 2. And right now, let's just pick tangent maybe. Tangent theta 2 is going to be opposite over adjacent, 5 over 10. So theta 2 is going to be, we'll say arctangent, 5 over 10. This is opposite over adjacent, by the way. So if you did inverse tangent, inverse tangent 5 over 10, or a half, you get 26, I'm going to call that 26.6 degrees, just like I expected. I did some rounding, so it's fine. That is how the inverse trig functions work. Just think about it as what used to be the input becomes the output, what used to be the output becomes the input. Hope that helps you out. Talk to you soon.